Can xAI win the battle for AI by outbuilding all of its competitors like OpenAI? Uh, Nvidia's CEO Jensen Huang seems to believe that that could be the case. Let me just provide that to everyone.
Right, to expand the size of that supercluster. You know, first talk to us a little bit about X and their ambitions and what they've achieved, but also, are we already at the age of clusters of 200 and 300,000 GPUs?
The answer is yes. And then first of all, acknowledgement of achievement where it's deserved. From the moment of concept to a data center that's ready for NVIDIA to have our gear there, to the moment that we powered it on, had it all hooked up, and it did its first training.
Yeah.
Okay.
Sure.
So that first part, just building a massive factory, liquid cooled, energized, permitted, in the short time that was done. I mean, that is like superhuman. Right. Yeah, and as far as I know, there's only one person in the world who could do that. Right. You know, I mean, Elon is singular in this understanding of engineering and construction and large systems and marshaling resources.
Incredible.
Yeah, it's unbelievable. And then of course, then his engineering team is extraordinary. I mean, and from the moment that we decided to go, the planning with our engineering team, our networking team, our infrastructure and computing team, the software team, all of the preparation in advance, then all of the infrastructure, all of the logistics and the amount of technology and equipment that came in on that day, NVIDIA's infrastructure and computing infrastructure and all that technology, to training, 19 days. The number of wires that goes in one node, the back of a computer is all wires. And just getting this mountain of technology integrated and all the software, incredible.
Right.
Yeah. So I think what Elon and the X team did, and I'm really appreciative that he acknowledges the engineering work that we did with him and the planning work and all that stuff. But what they achieved is singular, never
Right.
been done before. Just to put in perspective, 100,000 GPUs. That's easily the fastest supercomputer on the planet. That's one cluster. A supercomputer that you would build would take normally 3 years to plan.
Right.
And then they deliver the equipment, and it takes 1 year to get it all working.
Yes.
We're talking about 19 days.
Wow.
What's the credit of the NVIDIA?
So basically, then we can go off that it's basically 19 days instead of like a year, not kind of the planning part. And then Elon said it was 122 days, I think, from start of project to end of project, right? So that means like what with 3 years for planning for most places is 100 days for xAI. And they're also applying that to Tesla's system. So I'm going to discuss things about like one, how they did it, how I think they did it, some of the things that they had to do, as well as what this means for the competition for AI. So, one is what many people don't know, and Joe Justice, who used to work at Tesla, talks about a lot. He's an expert on agile systems. You've talked to him before, right?
Yes.
Is that Tesla can do things in a day, SpaceX can do things, all the Elon Musk can do things in a day that other companies can't do for months or years or whatever, right? In that they can get their budgets live, right? With scripts like, every few seconds they'll say, okay, here's the budgetary impact of that. They have scripts running that tell you, while other places, you have to do an annual report, roll it up, and then get that information. So it's like a real time. The SAP system. SAP system is really complicated software that you run a large enterprise on, but it's not real time. You're loading things up and you're running nightly reports. Even that is difficult to do. To go to real time on it is very difficult. Also, Tesla has stuff real time in the factory, where the first thing they plug in for the car is the monitor, the computer monitor. And then they plug in, okay, putting other components, other batteries, other systems. They connect that to the screen, and then it does instant by the second tests to see, did you put that in correctly? Hey, you plugged it in wrong, redo it. So when they talked about putting in all those hundreds of wires in the back of the system, I believe that xAI and then also for Tesla AI, that they have software in there to help test custom software for them that Supermicro and their other vendors have not fully built out, right? Otherwise, all the other vendors will be able to do the same thing to get things built up fast. So, and there's also the things that they've done on the factory side of things. So,
So if we step back and think about this, a little bit more top down. What you're talking about, of course, is that at every level, things are managed in such a way as you take out all the friction.
right.
So you might have you're planning I've done it. I've built factories. So you're planning to build a factory. You've got the facility. You've got the layout of the factory. But if you're not a small company like I was, you're a bigger company, you're going back before the board all the time to get approval to rent the building or to buy the building or to buy the land and then build the building. And all these things are coming back and forth with the C-level and then maybe with the board making all the decisions about what can or can't happen. Well, that all goes away at Tesla.
Right.
And they set up these, we set up some of these fast systems within our organization as well to manage the flow of things. But
Mhm.
Elon does it on a completely different level where he literally has a shadow factory the factory is in the computer.
Mhm.
And so when the planning that goes into that computer system, and now all you do is plug and play.
Mhm.
And if it's not the same as what it is in the computer tells you immediately,
Right.
sorry, this doesn't fit here. And so you get to make it on the fly change in that system. So I hope that's a little more of a detailed explanation of why they're just so fast.
And also it's a lot of the testing and just getting it right the first time. Like
Right.
that if you have to stand it up and do a bunch of extra things to test it, like when I've used to do stuff at computer departments, you'd run the program and then you'd spend, months testing things.
Right.
If it's a complicated program, I did run. Like if you do things right, you have a test suite where things are automated, and then you run the automated tests against it. You would have to have loads of automated tests. Everything would have to be automated on that. So they built Grok 2 was built on a 20,000 chip count thing. If you see the line fourth from the bottom, Grok 2 completed training June 2024, 50 days with 20,000 chip count. So that means that in April, they completed setting up their 20,000 GPUs, right? And however long it took to do that before that. I think it took them 3 months or 4 months to get those 20,000 set up, right? But they trained themselves to learn, I'm putting in these 20,000, I'm going to make another 50,000, 100,000 thing 5 times bigger. I need to get things automated as much as possible. So in that first attempt, they were, and getting to a Grok 2 system that is in the range of a GPT-4 class system. It's in the top five of the large language models, basically catching up, that they were teaching themselves and automating everything that they were doing. So they're ready to go for the next time. Because they knew, okay, we're going to keep doing this thing, right? And so then December 2024 is when this Alan Thompson expects Grok 3 to finish training with the 100,000 chips. So they just completed installing it, I think September, right? And now they're doing the training run, which they expect to be 50 days, right? So maybe they have to do some setup, some other stuff, and then they would be November, December would be when they do the training run on this thing, right? And then previously we saw Grok 2, their training run was done in June. Um, they then released it in August, right? So July, August, 2 months.
Mm-hmm.
They then released it. Other OpenAI, they've done their thing with, slightly fewer chips and stuff like that, although their GPT-5 will be 50,000. And they've supposedly done finished training in April 2024. They take 9 months to release. So again, more testing, more whatever that they're doing,
Right.
making sure, I think they're probably making sure there's some leftist bias to it or something like that. Anyway, so they're taking 9 months before they think it's safe to release into the wild. xAI is doing it in 2 months, releasing it, right? So whether it's just that they have testing less or whether they've automated more of their testing on that process to get it out. And I'm assuming that that still holds, right? That it's still it's 2 months and it's still the 50
Right. Right.
OpenAI is extending the time that they do the training, right? 95 days, 120 days. I'm assuming then they go to 150 days for a GPT-6. They have not released GPT-5, so we don't know. I'm ballparking January
Sure.
2025
Sure.
on that 9 month thing, right? So 16,000 chip years worth of training. Grok 3 will have 33,000 chip years worth of training. Llama 4 by Meta, they would complete their 100,000 plus chips in November, October, November. They were getting their chips earlier. They had 150,000 H100s at the end of last year.
Mm.
So that taking a year to
Yeah.
install it, that bears out what NVIDIA was saying. And NVIDIA would know. Jensen knows how long it's
Sure.
taking them to do it, right? So um, then they were going to skip up to 100,000 B200 chips, which could take them a year to get and do. So let's say you start getting serious quantities of B200s in Q4 of this year, maybe Q1, right? You won't get your full 100,000 maybe till like at earliest January, February of next year, right? And then you'd have to run it. Your setup could take a year. So 2025, by the end of 2025, you get it going, and then you do your training run in 2026, and then end of 2026, you then release,
Right.
right? So then for Grok 3, that same H100, they could release in February 2025, right? Because they already set it up and they run it 2025. So um, the Llama 4 might only be 2 months behind, right? Because it's November, I'm expecting them to set it up, have it set up, and then they do their 2 months of training. They're doing about 50 days as well. But then they take about 3 months to release. So then April 2025. So xAI pulls a little ahead with
Mhm.
Grok 3, but Grok 4, that's where the big difference happens. That's where they're getting um, H100 and H200 double the chips, going to 66,000. So superior in chip years finally to the competitors. And that will release June 2025. And then Grok 5 is the big leap where they have get the chips in the summer or in spring,
Mhm.
set it up, and then training could end October 2025. They check it for a couple months and they get it December 2025, having that 400,000 chip year system. I multiply it because the B200 is 4 times more powerful than H100.
I see. Right.
Llama 5 would probably only be about, I think, 100 to 150,000 chip years.
Mm.
Because it's 100,000, not 300, right? Because then being able to go to 300 and still maintain the efficiency of setting this big thing up. If what NVIDIA Jensen is saying is true, that they can set up more chips faster than anyone else.
Right.
That speed will then show up by getting a 1 to 2 year lead um, over the competition for the next like Llama 5, GPT-7 type systems. And we saw them catch up basically with the Grok 3 and get up to 100,000 finally, because Grok 2 had 20,000 chips and Llama 3 had 25,000 almost. GPT-5 is 60,000. So they're behind in terms of the number of chips. And they also were running them for less. They were ahead of Llama 3 for chip years in terms of training and the other stuff. So um, that that clear in terms of how the advantage I see playing out based on installing things faster,
Yeah. So I
building the
mean,
data center faster.
yeah. So this is, of course, been the story for Elon all along is how fast that he can get things done. His rapid iteration, rapid methodologies for having integrated the having again, as I pointed out earlier, having the software already create whatever it is that he's going to do in advance, and
Right.
then you just plug it in,
Hmm.
makes a massive, massive difference. I mean, it's kind of like if you think about, what a blueprint probably did for building,
Hmm.
so you have a blueprint and now you plug and play to the blueprint.
Yeah.
But when you've got a blueprint, there's only you're talking in two dimensions. Maybe you get a third dimension by layering the blueprint.
Hmm.
But now what you're doing when you start doing these virtual factories is you're in four dimensions,
Right.
because you're not only dealing with the three dimensions of reality, you're talking about the fourth dimension of how do things connect.
Right.
And so it just has to be incredibly fast.
Hmm.
And then the actual idea, just having the idea that you can do it that fast.
Right.
So part of it, I know I've told the story before at least once, but I'll just say it again. My partner used to scream and yell at me that we needed to be able to print bottles in 3 days from when they arrived, from when we got the order, because the advertising specialty industry required a 3-day turnaround. Yeah, you might pay a little extra for 3-day turnaround. Well, I yelled back at him and said, we can't do 3 days. We're 3 weeks. That's how we've always done it. Well, we finally decided to do it in 3 days. And so he started yelling at me that we should have a same day service,
Hmm.
because we could charge a lot more for a same day service, but that would really get us a lot of business. What are you talking about? A same day, in by 10, out by 5. Well, this company that couldn't do anything better than a 3-week turnaround, all of a sudden was taking orders in by 10 o'clock in the morning with artwork that we'd never seen before, and getting them out the door by 5 o'clock that night. Because why? Oh, because we said, let's try it. Maybe we can do it.
Right. So the thing is, for what xAI versus OpenAI and the other guys are doing, is that this 19-day to three versus 360-day difference is 20 times. It's like going from 360 days down to 19 days is a non-trivial thing. And it's like you're doing this kind of like D-Day action where
Yeah.
you're involving thousands of workers and a lot of things in order to like just physically 100,000 chips. If you had the same number for every day, right? You're going from roughly a little over 5,000 chips a day being installed and stood up racks, right? Versus someone else, like if they're taking 360 days, they're doing
Yeah.
300 racks, right?
Three,
So,
three a day.
no, one, 360 days, so 100,000, right? So
Oh,
that
okay.
means I'm taking,
30 a day.
um,
Hour 10 problem here.
well, 110 probably. Let me just do it. 100,000
It's
divided by,
19. Yeah, it's
oh,
19.
it's less than 1,000 a day, right? So basically like 1,000 a day would take me 3.6 days. So in one day, instead of 3.6 days for 1,000, it would be in the range of about 300, 250, 300, right?
Yeah.
That it would do per day. So again, that 20 times less is 250 versus 5,000, 20 times less than what I'm doing, right? So to step up to that next level, even say, okay, hey, you guys work harder, twice as many or something like that, right?
Right.
It's still a huge gap to overcome and to start because you must be doing things entirely differently in
Yeah.
order to get those things out. And you must be doing stuff on the testing and training side because he said that people were tested and trained, right? In terms of like staff and other things ready to go. So your entire project plan is entirely different in terms of like going to this faster uh, speed. It's just like when Boeing takes 2 years or 10 years to launch their SLS rocket versus, you know, SpaceX. Your entire project plan is entirely different,
Very different. Yeah,
right?
and you have to assume that that'll translate into the actual models that are being used, whether they're large language models at xAI or whether they're video models that they're using at Tesla. That same kind of thinking is being used with the development of these models and the methodologies of training. I've been very impressed by this last round of training, which I think is one of the hardest things I've had to try to understand in the entire LLM thing, of where they are now checking the work multiple thousands of or hundreds or thousands of times before the work is actually produced. You can actually tell ChatGPT, I guess, maybe Llama 2, you can say, take your time,
Mhm.
really make sure you've got it right.
Right.
And then it goes back in and rechecks itself.
Right.
I just have to think that Elon is probably even on a new level that will be even harder for my pea brain to understand when it comes to this stuff.
Because I think they were talking about the Shanghai factory being like 95% automated. This is the car
Yeah,
construction of the factory,
yeah,
95% automated. So it's porting over that kind of capability to an AI data center,
yeah,
right? To say anything that's manual, like all the other factories, Toyota, they have robots on the factory line just like everyone else,
yeah,
right? But
yeah,
they did not say, I'm going to completely revamp because it takes um, Tesla 1 hour to design, um, generate, like in a 3D model like that, and then certify their design. 1 hour for a car. Everyone else, it takes like 12, 18 months,
yeah, yeah,
right? So the scale of like to imagine, here's how I'm going to do it, and I'm going to get the hardware system and other stuff like that to make that happen. You have to like from the get-go think, how am I going to get to 100% on automation certification, right? So something insanely complicated, entire car, and then for the data center, the entire data center, right?
right.
You cannot like just do piecemeal. I'm doing the rack, and then we're gonna cookie cutter and stamp the racks. Then you get to, okay, I'm really, really good at this thing, and I did it in 360 days, right? It's like, no, the entire thing completely redone. I'm looking to do 20 times, 100 times what you guys are doing in
Yes.
1 day,
Yeah, yeah,
right? And then just the size of the models and everything. So I think this is you know, it's still the human and the software side of things applied to the AI, like creating the AI with the complexity and efficiency. And everything carries through where it goes to 300,000 chips. The bigger the scale, the more advantage xAI and Tesla AI have, right?
right, right,
Because they were kind of roughly okay at the 20,000 chip level, but when you
right.
went to even more complexity, 100,000, 300,000, and we're going to go to a million chips. Because, like everyone's trying to do the 300,000 chip thing. Like Jensen said, oh yeah, 300,000, yeah, we're there. Because he has the orders. Orders for Kuwait, there's orders going for massive data centers in North Dakota, a
Right,
$125 billion data
right,
center
right.
in North Dakota, right? So that's, power plants looking at 5 gigawatts of power, all this thing. It's like, you're building the Hoover Dam and the the data center and the factory with it, right?
Yeah,
So it
yeah.
is the industrial scale production that is the competitive factor. It's just like China gets China speed.
Hmm.
I build a nuclear reactor in 4 years instead of like 15 years. I build, shopping mall factories and stuff like that. So Elon has brought that to North America, right? To where he can say, okay, I can build an entire AI data center in 19 days. I can, with 100,000 chips, I'm going to make it more. And then I can toss in mega packs and other things, 10,000, 100,000, a million, and get the power solved. Because there's issues around power where these 20 megawatt data centers, they'll be chugging along doing computation, and then boom, they drop to like no power, right? So that breaks stuff, right? So handling massive amounts of power loads is something that Tesla Energy brings to, and also the SpaceX team can come along and provide, you know, next level solutions around materials and other stuff that could be secret sauce to enable these kinds of advances.
I've heard a little bit in the background, maybe you've looked at it more, that there's also something that Elon is doing with regard to the cooling systems that is very different down in Texas, maybe also in Memphis. Have you been paying any attention to apparently something pretty radical with regard to the cooling methodologies?
I know it's everything's still liquid, regular water cooling.
Okay.
I know that there were other companies, Dig or something like that, that were trying to make a computer with different chemicals that would
Mm,
have different kind of cooling there. Um, Supermicro and they're the biggest data center building company, um, is leading the way with their water cooling. But of course, Tesla and SpaceX, with their Octavalve and other things,
right, right.
and provide innovations around thermal management,
Yeah,
right? But I have not heard leaks around what it would be. I would expect that they would have part of that in there, and also the water cooling management issues,
yeah,
right?
yeah,
That is their stuff is next level. That they
yeah,
got some Octavalve like equivalent
yeah,
inside those data centers, which enable the cooling side to be that much more efficient,
right.
and also to be able to build it at modular and at scale.
Yeah.
So the fact that they can go to rapidly built modular data centers
Mhm.
is something that's huge for them. The other thing is that I believe that they're going to not just make these data centers here, that one of the first things that they will do on Mars is to bring AI data centers to Mars.
Yeah, yeah,
And we, oh, that's crazy, so much money, blah, blah, blah. So there other people, I don't know, Amazon, Meta, whoever, Microsoft are building a $125 billion data center in North Dakota
right,
using 5 gigawatts. On Mars, I can toss down, solar panels, 10 gigawatts, 100 gigawatts of solar panels. I just bring them on my Starships and I toss them out there. Even though, okay, I break 3 times as much because
right,
solar is less on Mars.
right,
I don't have to pay for the land.
right,
I'm there. No one else is going to stop me. I'm making it and I can pop out mega packs and do whatever I want there, right? So then, oh, it cost me like, um, $100 million to fly every Starship over there, right?
right,
Because I'm making them in volume, right? So then, 1,000 Starships, that'd be $100 million. We're still in the cost of $125
right,
billion on the North Dakota thing, right? So then, I set it up there. It's gonna take me, you know, uh, it could take SpaceX, with robots and stuff. It's gonna take me 3 months, twice as long as I take to do it here. Instead of 19 days or whatever, it takes 40 days, 50 days, whatever, right? And then they get that built there. They run the training for, a year, 2 years, and then you send the results back, right?
I see.
The result is just
A
a
pack,
super
packet.
model,
Yeah,
a
right,
model,
right,
right? That is like 100, terabyte
right, right,
model coming back, right? So that is like the perfect thing because like I'm sending stuff over there. I'm gonna leave it there. We're gonna build even more power, more chips. Next time I just bring some chips and a
right.
panel thing to scale up, right? So then and it's all be modular. So all the water management, heat things, they're all thinking about, I believe, on and then how do we bring it to Mars?
Yeah, yeah,
And
yeah.
by Grok 15, Grok 12, I'm bringing this all to Mars, and then we're getting back the supermodel that, super AI model that is like 100 times as powerful, right? Because I got a terawatt of power all on Mars, and I'm like, it got all the compute. Yeah, so it will get, what it, says it's gonna get weird. It's gonna get weird fast.
Very, very weird fast. Well, this is the world we live in. I'm sure glad that you and I are getting a chance to chronicle
Yeah,
some of the activity that this man is creating
yeah.
and his marvelous teams of incredible engineers that are around him.
Okay, let's talk again next time. Thank you.